To obtain 20 to 40% more heat from the same amount of fuel, it must be the combined heat recovery approach with active flue gas condensation and an absorption heat pump.
What is an absorption heat pump? How does it differ from a compression heat pump that you may know from residential buildings? First, it is powered by heat, not by electricity as compression heat pumps are. It needs a low amount of electricity for the circulation pumps of its liquids, which is less than 1% of the heat capacity being recovered. Where does the heat for driving the absorption heat pump come from? It comes from the combustion of biomass. If I now say that this box is a heat pump and the driving energy goes in, the low temperature goes in from the flue gas, and both energies together go into the district heating network. This means that the energy that comes from the boiler is fed through the heat pump and drives process, but it is not lost. It goes into the district heating network as before, and therefore I have no costs for driving this heat pump, thus no operating costs.
Heat pumps, whether absorption heat pumps or the widely used compression heat pumps, raise heat from a lower to a higher temperature level. Therefore, they evaporate and condense a working fluid at different pressure levels. Low temperature heat is supplied in the evaporator, and the working fluid is evaporated at low pressure. The source of the low temperature heat is the flue gas condensation system, i.e., the flue gas from the boiler. To keep the pressure in the evaporator low, the working fluid vapor must be removed. In a compression heat pump, a compressor draws off the working fluid vapor and simultaneously brings it to the higher pressure level, requiring electrical drive energy up to approximately 25% of the heat capacity generated. In an absorption heat pump, the whole process is achieved by absorbing the steam through a concentrated salt solution. The heat generated in the process can be fed into the district heating network return flow. The now diluted salt solution can then be brought to a higher pressure level with an electrical drive energy of less than 1% of the heat capacity generated and pumped into the generator. To maintain the process, the salt solution must be concentrated again. To do this, it is boiled in the generator so that the water evaporates. The supply flow from the biomass boiler is partially used to heat the generator at a temperature of at least 105 degrees Celsius. The now concentrated salt solution is then fed back into the absorber, and the resulting vapor is condensed in the condenser at a higher pressure level, and the heat is transferred to the district heating network return flow. To clarify all the requirements for a highly efficient heating plant with an absorption heat pump, it is necessary to carefully design the overall system.
The absorption heat pump works almost 100% independently. No man-hours are required.
Biomass is a valuable resource, and we need to use it more responsibly in the future, and even better if you can do it in a way that pays off.